gradient of a scalar field in Cartesian coordinate systems. So it means del s, whereas uh, del, right, this is yes. So this is the gradient of a scalar field. So for this, what by definition, what is del? Times dou by dou x, yes, plus delta y dou y, yes. That means simply dou s by dou y plus delta z dou s by dou z. So this is a gradient of a scalar field in Cartesian coordinate systems. Now, if we want to write it in cylindrical coordinate systems, so del, and then if I write this as cylindrical coordinate systems, what is del operator which is defined? So this is like this plus dou theta 1 by r dou by dou theta plus delta z dou by dou z. So this is a del operator in cylindrical coordinate systems and scalar quantity. So simply it becomes delta r dou s by dou r delta theta 1 by r dou s by dou theta plus this is Kronecker delta and then it becomes dou s by dou z. So this is in the cylindrical coordinate systems. Now if we want to write it in spherical coordinate systems, so first of all we need to define what is the del operator. This is again plus dou by dou r plus dou theta 1 by r dou by dou theta plus this is very important now. This is dou phi 1 by r sine we have written earlier, right? 1 by r sine theta dou by dou phi. So you should be careful in defining this particular term. This is yes. So simply what happens to this particular term in total? So this becomes r dou s by dou r 1 delta 1 by r dou s by dou theta. Okay, so this is how gradient of a scalar field in spherical systems is written. So the next part will be the directions or different components of this particular what do you call vectors. See, once you say there is a vector, it should have components, right? It should have components. So what are those components? So these are the components. Once you write, you know, gradient of a scalar field. So these are the components of that particular vector. So this is formed by the gradient of a scalar field in Cartesian coordinate systems. This is found by the gradient of a scalar field in cylindrical coordinate systems. This is found by the gradient of a scalar field in spherical coordinate system. So there are the coordinates what we are writing, what we are trying to write are x comma y comma z, right? That means x direction, y direction, z direction. Here r comma theta comma phi. Here r comma theta comma the cylindrical coordinate it should be only z. Spherical coordinate systems r comma theta comma phi. So this is this portion. What we are seeing is a gradient of a scalar field. Similarly, there will be gradient of a vector field. We'll see that in the next session.